Welcome to the world of discrete electronics. Step into a realm where precision and creativity converge, where circuits come alive through individual components working in harmony. Discrete electronics is the art and science of crafting systems, using standalone elements like resistors, capacitors, diodes, inductors, and transistors. Let us build Infrared Sensor Robotic Eye. There are various applications of IR sensors, such as TV remote controllers, burglar alarms and object counters. Here we have used IR sensors, infrared LEDs, to make an object detection circuit and also a proximity sensor for path tracking robots. The basic idea is to transmit the infrared light through an IR LED, which is then reflected by any obstacle ahead and sensed by the receiving LED. This circuit is an IR, infrared, proximity sensor based on the LM358 operational amplifier. IR LEDs, IR LED1 and IR LED2. These are the infrared transmitters. They emit infrared light. When an object comes near the sensor, it reflects the infrared light back toward the circuit. Photodiode or IR receiver, connected to the base of T1. This component detects the reflected infrared light from an object. The reflected IR light generates a small current, which is amplified by the transistor, T1. Transistor T1, BC548. It acts as a signal amplifier. When the photodiode detects IR light, it triggers the base of T1, allowing current to flow through the collector-emitter path. Zener diode, ZD1. The Zener diode ensures a reference voltage, 2.2 V, to stabilize the operation of the circuit. Variable resistor, VR1. This 10 k-ohms potentiometer allows fine-tuning of the sensitivity of the circuit. By adjusting VR1, you can set the threshold for the LM358 to trigger. Operational amplifier IC, LM358. The LM358 is configured as a comparator. It compares the voltage at its inverting input, pin 2, with the non-inverting input, pin 3. When the voltage at pin 2 exceeds the voltage at pin 3, the output, pin 1, goes high, activating the relay driver circuit. Resistors, R1, R2, R3, R4. These resistors limit the current through their respective components to protect them and ensure proper operation. R1 and R2 protect the IR LEDs. R3 and R4 are part of the operational amplifier and LED circuits. LED1, this LED serves as an indicator. It lights up when the IR proximity sensor detects an object and the output of the LM358 is high. The IR LEDs continuously emit infrared light. When an object comes into the sensor's range, it reflects some of the IR light toward the photodiode. The photodiode detects this reflected light, generating a small current, which is amplified by transistor T1. The amplified signal is fed to the inverting input, pin 2, of the LM358. The voltage at the inverting input is compared with the reference voltage set by VR1 at the non-inverting input, pin 3. If the voltage at pin 2 exceeds that at pin 3, the LM358's output, pin 1, goes high, lighting up LED1 and activating the relay driver circuit. Applications like object detection, obstacle avoidance in robotics, line-following robots and automatic lighting systems are excellent use cases of this circuit. Stay tuned and keep learning. Subscribe to our YouTube channel www.codingscientist.com.